Good evening. Today I would like to talk about dynamic arrays. So in order to know what a dynamic array is, I will just show you how it works in higher level languages. For example, in JavaScript. In JavaScript, an array is an object like this. And in JavaScript, you can append any data you want to an array, and it will just grow as much as you want. So in order to do something similar in C, we need to implement a data structure of our own. And let's start by defining some data types. Shit. Okay. Yes. So I'm going to start by defining data types in a header file. And since this is a header file, I'm going to use this macro. And this is a trick used by using C code to make sure that each header file is only loaded once. And inside here, and inside it, we can define a type def, and this is going to be a struct. And inside this struct, I'm going to call it just array. We're going to have an array of something. And for this simple example, we could say this is going to be an array of integers. And later on in the video, I would like to expand it on more complex types. So I'm going to include stdint.h. And also I'm going to use int64 t. I call it items, and this is going to be a pointer. And also we need to store the current length and the current capacity. Actually, we should probably call it count. And size t comes from, I think it comes from std_def.h. Okay, great. And we're going to need several functions. We're going to need one function to initialize the. We're going to need to initialize the array, and going to be init. I'm going to call it init array, and it's going to take a pointer to an array. We're going to need a function to add a new element to the array, and it's going to take a pointer to the array, and it's going to take another element that we're going to push to the array. And then is there anything else this example was using? Yes. So let us go to the implementation, and I'm going to include this header file, and let's write some implementation. So firstly, we initialize the arrays, the items to a null pointer. No, not this one. And then we set the capacity to 0 and count to 0. This way, when we start with an empty dynamic array, it's going to be empty, and we do not need to allocate any heap data for it. And Then in the right array function, we're going to need to check if the array's capacity is less than the array's count plus 1, then we need to grow the array. And then if once we have grown the array, we push a new items to be we push the new item to the element pointed to by the count equals item, and then we increment the count. So this way, if our array is empty, we need a way to grow it. And I'm not sure if I have mentioned what this video is going to be based on, but I'm basing the tricks on a book called Crafting Interpreters, which, by the way, is an amazing book. And I'm going to use some examples of code from this book. So in here, we're going to need this particular book uses an example of a macro, and we could do it in a macro, or we could do it not in a macro. I guess you could just inline it like this. Size t equals if arrays size t new count equals if arrays capacity equals 0, then is less than 8, then we return 8, and if it's greater than 8, then we use the existing capacity times 2. So basically, if we start from 0, we if we start from 0, we basically just assign 8 elements. This is an arbitrary number, but I'm guessing 8 will work okay. And then we just grow it and like with every time we need to grow it, we need to double the count, double the capacity. And there are other approaches to this problem as well. You could use a Fibonacci sequence, but doubling is okay. And then we're going to define a macro. The reason this is done in a macro in here is because this book uses this macro for different types of It's using this like generically, but actually we could probably just kind of inline it. So we know the new count, and we know the new capacity equals new count times size of int64t, and then we reallocate. So we're going to have to use stdlib because we're going to call realloc, and we are going to use the existing pointer, and we are going to set the the new capacity. Oh, and by the way, I'm going to call this new size because this is size in bytes, and we are going to assign this return pointer to the existing pointer on the array. So this way, potentially, we could just so this way, if we want to push a new item onto the array, if we have enough space, we're just going to put it there. If there is not enough space, we're going to have to allocate new space. But luckily, this function realloc, it functions like if there is enough space, it just does nothing, I think. And if there was, it basically handles perfectly fine the intricacies of having to copy or move data. So now that we have something like this implemented, let us try to use it in an actual program. So I'm going to define an array, and we first are going to initialize this array. Why don't we get init array r, like so, return 0. So first, let's see if this even compiles. Okay, cc o main, and then we're going to include main.c and array c. Okay, this it ran and we didn't get a segmentation fault, which is already a good start. So now let us try to write some elements to the array. So basically, I'm going to try and get some random data, at least pseudo-random data. Sorry for that. Let's see where random actually comes from. Okay, this is man3 rand. Okay, it comes from stdlib, so h. So let's just say for int I equals 0, I equals 120, I plus I, and then we're going to generate a new random number equals rand. What type does rand return? It returns an int. Okay, let's say we just want it to be less than 1000. So we write a new element to this array, and then at the end of this program we can say tell me the current size, your current capacity, and tell me your current count. So our capacity, our count, like so. Oh, and we need to include stdio. So let's see. Fatal glibc error, malloc assertion failure in sysmalloc, all top equals initial top, AV and old size equals 0. Unsigned long old size is greater than minimal size. Okay, but doesn't look too promising. Have we initialized the array? We have. So this means I'm going to have to debug. So instead of compiling this with CC, I'm going to compile it with Clang, so we can use GDB. And I'm going to open it up in LDB and set a breakpoint to first I'm going to set a breakpoint at main C line 9 and run. Okay, at this point, what do we have in array? We have a count which is bollocks. Are we correctly? Yes, we are correctly initialized. We have a null pointer in here, we have count of 0 and capacity of 0. So, oh, I think I know what happened. We haven't set any capacity. So array capacity, yeah, I'm just going to put it here. Array capacity equals if the existing capacity is like so. Let's see. Does it work now? Okay, so now we have it tells us that it worked, and we could probably just try and see what is there in stock for us. So for int I equals 0, I is less than arrays count, array I++, printf the index of the element and the actual element. So the index is going to be I, and the actual element is going to be arrays items at index I, and this is not a pointer, so this is array.count, like so. So now if we scroll up, we are getting basically an array of 120 pseudo-random integers, which I guess is nice. Okay, so at this point we already have an array that can grow. And probably we don't really need to, for most purposes, if we are only going to be using this to allocate memory for an amount of data that is unknown at the type of compilation, and we cannot make sure how long the array is going to be before we have to allocate it. For example, because we are fetching data from a database, then we may want to I mean, this is enough, because this grows, and if we want to remove items, we can just allocate a new array and copy data. I guess this is not a big deal. And now we have an integer array, and let's expand it to something more useful, I guess. And I would like to use this with a SQLite database. So in one of my previous videos, I have talked about opening a SQLite database in C, and in fact, I do have some SQLite databases that are very big, and they could be good examples, but I haven't prepared for that. So let's just use the database from one of our previous videos. And this is going to be probably a bit underwhelming, because in the database we only have two items, and I'm going to copy the SQLite download script. So I'm going to quickly show you the download script. This is something I wrote after writing one of my previous videos, and this is a shell script that will download SQLite version 3.49, and it will unzip it into the current directory. So there is currently no easy way to download the latest SQLite version, so we have to rely on workarounds like this. So it basically says if there is no SQLite 3.h file in the current directory, and if there is no SQLite 3.c file in the current directory, then it will download a release, which will verify its integrity, and it's going to unzip it. And also, I could probably do it in the reverse way. If these files exist, then we exit with the zero exit code. So I'm going to quickly run this program to download the amalgamation to this directory. And this program is running with the +x flag, which means every single operation is echoed before it's executed. So now in this directory we have this SQLite.c file, and we can compile it to a shared static object. It's not a static object. We're going to we can share it. We're going to compile it to a format that can be used by the compiler, so that we do not have to compile the database every single time. 3.0, and I'm going to compress it. I don't really know what this does, but I guess I'm going to check it before the next video, like this. So now, if we wanted to compile the program together with SQLite, it's going to be very easy. And when you just put array.c, main.c, and libsqlite a, and it like this, it was linked. Great. So in the database in here, I have data about some products. Let me just quickly show you what we have. So we have select count from products. We have 2 products, and their titles and base prices are as follows. So we basically have 2 products in the database, and we could try and select them in the program. So I'm going to delete all of this. I'm going to make a snapshot using JJ, so we can maybe reuse it if you wanted. So I'm going to remove all of this, and I'm going to completely ignore all this for now. And now we could say include SQLite 3.h, and let us connect to the database. SQLite 3 open, and this function takes the name of the database we want to open and a pointer to the database. And if the operation was successful, it should return a constant called SQLite OK. And you can say if it was not OK, we print out to standard error that failed to open database, and we print the error code and exit 1, like so. And I think we need to do a SQLite free close, although it probably wouldn't really matter. And then we have this prepared statement that we could use. So we can say SQLite free statement pointer stmt rc equals SQLite free prepare d2 with the pointer db. The SQL text is going to be select, let's just select title and base price, and then we pass product. Yeah, I forgot, from products. To this third argument we pass -1. This way the SQLite engine is just going to go over the SQL and parse it until it finds the null terminator, which means it's basically automatic. And then we pass a pointer to the statement, and to the last argument we can pass null. So if rc does not equal SQLite, okay, then we can say we print an error message, failed to prepare statement, like so, and SQLite close db exit 1, and let's see if we can run it like so. So I have this command. Okay, so with this command, let's see what it says. Okay, it doesn't say anything because we did not select any, we did not print anything out. Anyway, right now we have an array type that only supports int64s. So instead of that, we could also define a type which is a struct for our product, and this is going to have a char pointer called title, and this is going to have a double which is the base price, like so. So now let's say we wanted to define as a data structure which is going to store an unspecified number of products. So basically we can just copy all of this, and instead of calling it array, we call it product array, and this is going to be a product pointer, and we define a function called init product array and write product, and this pointer is going to be a pointer to a product array. This is going to be a pointer to a product array, and the item is going to be a product. So this way, in array.c, we could basically do the same thing. So let's just write an repetitive code, and then we can think of ways to clean it up. Init product array, it's going to be exactly the same as this one, and in here I think the only difference is going to be that the product array item. Okay, so I think the only difference is that this is going to be size of product as opposed to size of int 64 int. So everything else is the same. And I guess that's why in the book, in this book, we are just using 2 macros. So let's see how these macros could help us. Okay, so firstly we have this line which says if array's capacity is less than 8, we return 8, and if it's otherwise we return the existing capacity times 2. So what does it say? Grow capacity. Okay. So we can say in array.h, let's say define grow capacity of the current existing capacity, and we can just say if capacity is less than 8, return 8, otherwise return capacity times 2. Okay, and we can use it here. So we can say grow capacity arrays capacity. Okay, so far so good. And now this macro is a bit more tricky because it uses also this needs to be a macro. It cannot be a function because it uses a type argument. So it has to be processed before compilation in the preprocessor. So this basically expands to a call to reallocate, and reallocate returns a void pointer and takes a void pointer. So we need to cast the returned pointer as a pointer to the type we are going to use. So so in this case, let's see, in array.h we define grow array, and the array and this macro takes a type pointer, and it currently doesn't really use so the reallocate function is not really using the old size, but we could keep it this way: old count, new count, reallocate type asterisk reallocate pointer size of type times old count size of type times new count, like so. Yes, so this was reformatted by Clang format, but it means the same thing. We're calling to a function that is going to return a pointer. So in here, I'm going to declare this function, reallocate void pointer size t old size. Is it old size? Yeah, we can call it old size t new size. And then in this reallocate part, we could also use this reallocate function to free the existing array if you want to shrink it. This is not going to happen at this point, but it is a valid use case. So let's say okay, in this array.c file, let us define this function void reallocate, void reallocate. Why didn't we get this autocomplete? Reallocate void pointer Okay, I don't know why we are not getting autocomplete, but void pointer size t old size t new size. So now if new size equals 0, we free the existing pointer and return a null pointer. And otherwise we return realloc pointer and then new size, like so. So instead of just calling the realloc on our own, we could say we could call reallocate. And how does this work in here? How is this used? Where does this book use reallocate? Okay, oh, it does. It uses grow array. So we need to know the old capacity, and we need to so size t old capacity equals array capacity equals grow capacity old capacity, and then the new size, we don't have to calculate it, we just say array items equals grow array, and then the type here is going to be int64t, and the pointer is array items, and old capacity, and array capacity, like so. And now we can remove this, and we could probably do the same thing for the product array. Okay, int size t old capacity. Okay, and this we need to grow it with pointers. So at this point, this is becoming very repetitive, and I'm still wondering how we could handle this like in a more generic way, because technically a pointer is just a pointer, and we could just store data in use a pointer, and we could just probably cast it at the point we want to use it. Okay, so when I started this video, I wanted to showcase how we could do this, but it seems like I cannot really do this myself. But anyway, I'm just going to show you how you can use a dynamic array to fetch records from the database. So in main.c, we're going to need to allocate a product array, like so, and initialize it. And then for every row returned by the statement. Yep. So in SQLite, I have already discussed this in one of my previous videos. In SQLite, when you want to execute a query against a table, you need to prepare it, and then the actual SQLite operation is going to be executed once you call SQLite free step. And we want to make sure this returns SQLite row, because this means that the operation returns a new row, and this statement, it's going to return rows, and they're going to have as many rows as there currently are in the query. So you can say product, and we're fetching title and base price. So we can fetch the value from the database using SQLite free column text statement, and this is going to be, I think, first column, like so. Okay. And yep, we have to cast it to char, otherwise it won't let us, it will complain about types. To char, we have to cast it to a char pointer. So now this is going to return a buffer, and for now we can just say print this buffer, and I compile it. Okay, I think this is 0, like so. Yes, so the columns are 0 indexed, as it turns out. So the operation returns a char pointer, and if we wanted to store it on this struct, we could try to do it like so. This is a naive approach. So we could just say the product's title equals buffer, and then afterwards we can just say for int you can iterate over the products in the array. I is less than arrays count, I++, and then let's print so product equals array items ith element of this array, and then we can try and say product title, and let's see if this works. It should not. Okay, what just happened? Oh, because we didn't push it to the array. Okay, let's say write product array and product, like so. Compile it. Undefined reference to write product. Why? Did we implement this in array C? No, we did not. We called it write product array. So the name was incorrect. So now, if we try to run it, we are getting garbage. And the reason for that is because in main.c we are just assigning this pointer to the field on the struct. And the problem is that this title it is allocated by SQLite, and it's only meant for temporary use. So if we want to store it on a struct, we actually need to allocate a new buffer and copy it. So for that, we're going to need to know its length, and it is returned by SQLite 3 bytes. Statement 0. This returns the length of the column at index 0, and the product.title, it has to be needs the size of length plus 1, because we need space for the null terminator. And now we can say string copy. I think this comes from string.h. String copy. We copy it into the product's title. No, product title. We copy it from the buffer, like so. So now, let's see if we get proper data. So what just happened is that we now have a dynamic array of products, and we fetch data from the database and store it in the products, and then we can use it later on in a different loop. So we can reuse the same data over and over again. And this is exactly for this purpose we needed a dynamic array. So I know this may be kind of underwhelming, considering that I haven't managed to generalize it, or I only have two products in the database, but the general idea is the same. And in this video, I just wanted to showcase what I learned yesterday. And yes, also, if you are still watching at this part of the video, I have a question to my audience, because I tried to build a new setup. I'm going to the Philippines next week, and I didn't want to bring my big microphone. This is my Blue Yeti microphone. It's a great microphone, but it's kind of bulky. And I wanted to bring a smaller lavalier type microphone. And for some reason, I have tried, this is the microphone I bought is a Rode lavalier 2 microphone, and it is supposed to be very good. Everybody online is talking about how great this microphone is, and I tried just connecting it to a laptop using a TRRS adapter, and it does produce sound, but the sound is terrible quality, and this signal is just way too strong, and the sound is pretty bad. It's the pitch is too it's terrible. It's so bad. It's so bad you cannot even make out every single word. So I just thought, okay, maybe I'm just using a cheap Chinese adapter. Maybe I should get a new TRS adapter. And I got the Rode branded adapter, and it came in the mail within 8 hours from the order, and it doesn't help. It's still terrible. So if somebody in my circle of friends has said that if you could try to do this with a recording card that you plug into the a USB based recording card. If you have any experience with cards like this, please let me know. You don't even have to do it in the comments. I really just need to know how this works. But anyway, you can find my email. If you do not want to talk to me in the comments, you can find my email address on my personal website. And the website is linked in the description below. And yep, I guess I'm not going to stretch this video for too long. I hope you have enjoyed my quick monologue, and if you have the opportunity, please go and spend the Valentine's evening with somebody you enjoy spending time with. And if you have enjoyed this video, please consider liking and subscribing. If you think I'm just talking bullcrap, this is also fine. I am making these videos mostly to learn myself and to learn to speak. It's okay if you don't enjoy it. Anyway, thank you for watching, and I'll see you next time.